Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hi everyone. My name is Muhammad Hazib bin Zulkifli. Today I would like to present about my final year project. The title of the project is The Effect of Camshaft Degreeing Towards Performance of a Passenger Car. Dr. Norizam bin Muhammad Ja'ad is my supervisor, and Sir Saiful Fazil bin Zainal Abidin is my CO supervisor. So we go to the abstract. The word degreeing camshaft means ensuring that the position of the camshaft in the engine coincides with that of the crankshaft. In order to synchronize their rotation, a procedure known as camshaft degreeing is employed to determine if a camshaft meets the manufacturer's specification. This research was conducted with a laboratory setup to analyze the performance of power and torque produced from each advanced and retarded exhaust timing of the passenger vehicle using Mustang chassis dynamometer. The test is conducted using 1.3 liter engine of Proton Saga FLX, which has been changed to adjustable cam pulley for the exhaust. In addition, two types of tests conducted, which are full load test and part load test. For full load test, each of the exhaust cam pulley adjustment tested on wide open throttle using fourth gear on the dynamometer. For part load test, each of the exhaust cam pulley adjustment tested on the dynamometer to record the torque produced using fourth and fifth gear at 2000 rpm and 2500 rpm. Generally, advancing the exhaust cam pulley results the exhaust valve to open and close sooner, while retarding the exhaust cam pulley will result the exhaust valve to open and close later. This result indicated that the later the exhaust valve open, the more torque and power gain at low RPM, while the sooner the exhaust valve open, the more high RPM power and torque gain. It is confirmed that the objective of this study were achieved. The vehicle tested on the power curve test was identified, and the amount of power and torque produced by the effect of exhaust cam pulley adjustment were studied. For the introduction, the word degreeing camshaft means ensuring that the position of the camshaft in the engine coincides with that of the crankshaft. In order to synchronize their rotation, it is the only way to know whether the piston rise and fall matches the valve opening and closing correctly, so that the engine works properly. A few degrees of misalignment can have dramatic effect on the engine. The relative position of the camshaft to top dead center (TDC) affects the valve timing events across the entire firing order, which can have substantial effects on the resulting horsepower and torque curves. Degreeing the cam not only ensures that the cam can account for manufacturing tolerance, but also allows a builder to adjust the cam timing for performance. The objective of this project is to study on achieving the correct valve opening and closing points of the engine, and to study the effect of advance and retard on exhaust camshaft towards performance in terms of power and torque. The scope of this study are: the degreeing camshaft experiment will be conducted by using actual vehicle, which is Proton Saga second generation FLX 1.3 liter. Adjustable cam pulley, degree wheel and dial gauge will be used for degreeing camshaft process. Engine performance analysis will be based on power and torque on the dynamometer chart. For the literature review, as we can see from the table above, the table shows the findings of previous article related to camshaft overlap and performance, variable cam timing, advancement in variable valve actuation, and fundamentals internal combustion engine. Next, for the methodology, after identifying the problem, objective and scope of this project, doing some literature review based on previous articles related to effect of camshaft degrading towards performance. Then, define the experimental parameters as the project will run using Mustang chassis dynamometer and advance or retard exhaust camshaft by using adjustable cam pulley. The test started after the engine warmed up for about 15 minutes. The data of engine speed, torque, and power will be displayed on the connected PowerDyne PC. Data collected will show the engine speed and the performance produced from the experiment. For the experimental method, first is the degrading camshaft, which is finding the top dead center. The top dead center mentioned is the position of piston number 1 at the top and the position of valve in a closed state for intake and exhaust. This position is called compression stroke in the cycle of 4-stroke engine. Then, find the open and close of exhaust and intake valve. All of these processes were done by using dial gauge indicator and degree wheel that attach to the crankshaft pulley. Then, drive the vehicle from first gear to fourth gear until engine speed shows around 3000 rpm and release the throttle pedal until it reaches 1500 to 2000 rpm and click start test at the dynamometer monitor. Go for wide open throttle WOT until 4000 rpm. The test displays the power and torque produced from the power curve test. There are a total of 4 tests, 4 wide open throttle tests. That is the standard exhaust camshaft setup, advanced 5-degree exhaust, retard 5-degree exhaust, and retard 10-degree exhaust. For part load test, drive the vehicle to 4th gear, maintain it for 2000 rpm and 2500 rpm. Then drive the vehicle to 5th gear, maintain it for 2000 rpm and 2500 rpm. The test displays the torque produced from each of the part load tests. The test repeated in each advance and retard of the exhaust camshaft. In order to collect the data from camshaft centerline, experimental procedures were carried out. In each advance and retard of the exhaust camshaft, the vehicle test is then collected in full load and full load and part load test. The torque and power produced by the test vehicle are collected by the end of this experiment. After that, discussion and conclusion has been made based on the graph of the torque and power obtained from the dynamometer. The main purpose for the result and discussion, the main purpose for camshaft dial cam in this experiment is to know the original centerline camshaft. This is because when the original cam pulley is changed to adjustable cam pulley, it is likely that the centerline will slightly not follow the original spec. In this experiment, after being converted to adjustable cam pulley, the dial cam process was rerun to ensure the centerline camshaft was as original. Therefore, this vehicle is allowed and ready for the next experiment, which is dynamometer power curve test. Okay, for power curve full load result at low engine speed 3250 rpm, the power increased by an average of 1% for advanced 5 degree, and it shows no power improvement from 3250 rpm to 4000 rpm compared to standard exhaust setup. This is due to valve overlap were reduced. It can be seen that retard 5 degree has little improvement of power at low engine speed and significantly increase at middle rpm compared to standard exhaust setup. This is due to valve overlap increase. It is induced more air inside the combustion chamber, thus produce more power. Meanwhile, for retard 10 degree experience power drop significantly at low to middle rpm compared to the standard exhaust setup as the valve overlap goes further increased. This is possibly due to excessive exhaust residual inside the combustion chamber due to bigger overlap. Higher residual will lead to lower combustion efficiency, therefore the power reduced. Okay, for part load test result from the graph, at 4th gear 2000 rpm and 2500 rpm shows that advanced 5 degree produce 1.4% higher torque than standard exhaust setup. It is also shows that retard 5 degree produce 2% lower torque than standard exhaust setup. It can be seen that retard 10 degree produce the lowest torque among all exhaust setup. On the other hand, at 5th gear 2000 rpm show that advanced and retard 5 degree significantly increase on torque, and at 2500 rpm shows that the standard exhaust setup was slightly highest among advanced and retard 5 degree exhaust. Meanwhile, retard 10 degree produced the lowest torque among all of the setup. This figure is also illustrate that the larger of degree of overlap of the camshaft, the greater the power produced. But however, a lot of overlap may also make the engine run poorly at low rpm. This possibly due to exhaust gas managed to preserve the intake manifold, dilute the incoming charge of air fuel, and create soot on the intake runners. This is because the amount of fuel and air mixture entered is increasing, so that the combustion process can be powered during the compression cycle of both. So for the conclusion, last but not least, the different adjustment exhaust cam pulley have shown that it will affect the vehicle's engine performance by measuring the amount of torque and power generated by the engine. Advancing the exhaust cam pulley will result the exhaust valve to open and close sooner, while retarding the exhaust cam pulley will result the exhaust valve to open and close later. Exhaust opening occurs near the middle of power stroke after the spark plug is fired and flame front expanded, and it pushes the piston downward. Once the exhaust valve opens, the exhaust begins exiting the chamber and cylinder pressures drop rapidly. Then the combustion chamber is now used to force the burn mixture out of the exhaust. During the exhaust stroke, the remaining exhaust gases will be pushed out by piston and making room for the next charge of air and gas mixtures. Thus, the later the exhaust valve open, the more low RPM torque gain. The sooner the exhaust valve opens, the more power curve will carry past the point of peak horsepower due to the both reduced exhaust pumping losses and the exhaust having more times to free itself of the chamber. The exhaust valve begins to close just after the piston starts downwards. The reference of this experiment as shown above. That's all from me. Thank you and have a nice day. Assalamualaikum warahmatullahi wabarakatuh.